Okay, welcome to another tutorial on this one's on the mole and calculating the molar masses. Okay, the mole is a commonly used term in chemistry. That's a little bit thick, sorry. Shrink that down. Okay, the mole helps us keep track of how much stuff we have. So what is the mole? Well, it is a unit of measurement. Okay, it's very similar to, we know, and everybody knows that 1 dozen equals 12 whatevers, 12 eggs, 12 cookies, 12 donuts. Okay, a mole says that 1 mole equals 6.02 times 10 to the 23rd atoms, molecules, AMUs, whatever. 1 mole equals that many donuts. Okay, so just like 1 dozen equals 12, 1 mole equals that number. That is called Avogadro's number, or 6.02 times 10 to the 23rd. Written out, it would be 602 sextillion. It is a very, very large number. How big is the mole? Well, if you had that amount of money, you would have to spend $1 billion a minute for over 1 million years to equal that. That's very large. Okay. Now, so we use the mole to keep track of what we have. So sorry, let me just finish changing this up. And you have this mole, 1 mole equals 6.2 times 10 to the 23rd on the back of your periodic table. Now, if we want to calculate atoms to moles, we're going to use that as our loaner. So 8.05 times 10 to the 23rd. My proportion is 1 mole equals 6.02 times 10 to the 23rd atoms, molecules, etc. So 8.05 times 10 to the 23rd. Let's see, I made a mistake there. Let's go back and fix that. I did not put the units. You've got to put the units, otherwise nobody will know what you're talking about. So that is atoms. Okay, my goal is moles. So I know that 6.02 times 10 to the 23rd atoms equals 1 mole. Well, atoms cancel, atoms cancel. I go through and do the math. If you see an E on your calculator, that means times 10. I do the math here and I find out that I now have 1.34 moles. Okay, sorry, I'm getting new at this device here. Okay, and so you'd go through and do the rest of those. This one, loaner, loaner, atoms, atoms, atoms. As we scroll down, we have, now you're going to flip it here. And you would start with 5 moles. And now 1 mole will be on the bottom. 6.2 times 10 to the 23rd would be on the top, and that would be in atoms. Cancel, cancel, 5 times that, and you'd get your answer there of 3.01 times 10 to the 24, 10 to the 24 atoms. Okay, again, people always say, well, how do I know what goes on top and bottom? Well, it's all about your units. This is a proportion. Just like 1 mole always will equal that, or 1 mole equals something different in a gram. And that's what we'll talk about right now. So now, what we see is that moles and atoms are very nice, but they're not useful in a lab setting, so we have to change it to grams. So we will calculate the molar mass of different elements and compounds. Okay, to find the molar mass for elements, we look on the atomic mass on the periodic table. So, oh, I didn't mean to do that, because I'm still figuring this out. Okay. I'm just going to make that default. Okay, as you look on the periodic table, let's take carbon for instance. We know that the molar mass of carbon is 12.01. The atomic number is 6. That 6 tells me how many protons I have. This tells me my number of grams per mole. So that means if I have 12.01 grams, I have 1 mole. 12 grams of carbon atoms will weigh 1 mole. And you can go through and look at all these to find out what you have. Now, to find the molar mass of a compound, we have to count how many atoms in here. And this is always a tricky part for students. We have 8 carbons, 18 hydrogens, 3 calciums, but that 2 gets distributed. So we would have 2 P's, and you multiply, so you would have 8 oxygens. Okay. Parentheses you have to distribute, just like in math. Okay. And then we will multiply the number, multiply the number of each one. So here, I would have to go three times 40.078. That's came from the molar mass of calcium on the periodic table, plus 2 times 30.97, plus 8 times 15.99. Okay, all of these come from the periodic table. 8, 2, and 3 come from my subscript right there. You would add all that up and you would find out that the molar mass of calcium phosphate is 310.09 grams per mole. Okay, now we have a proportion there, so now we can use that in the picket of fence. You do the same thing here. 2 times 1.01 plus 2 times 16.0, or 15.99 depending on what you're looking at. Okay, and what that number tells me is that if I have 310 grams of that compound, I have a mole. So I would have 6.02 times 10 to the 23rd molecules in a 310 gram sample. Okay, keep practicing the rest of these and trying to find the molar mass. And molar mass is a skill that we will need throughout this whole lab book. Okay, thank you. Good luck.